This video lecture is meant to help you understand ionic compound formulas, and essentially what we're going to do is take an ionic compound formula and dissect it and figure out what cations are present, what anions are present, and how many of each are present. In our first example, we see the compound formula is CaCl2. This is calcium chloride. If you were to take that formula and uncrisscross, effectively taking the subscript of 2 from the chlorine and bringing it back to the calcium, the cation, that effectively tells you that the charge on the cation was a +2. The understood 1 on the calcium effectively becomes the charge on the anion, so chloride was a -1. So what we see here was that there is 1 calcium +2 ion. The subscript here, number 2, next to the chloride, tells you that there were 2 chlorides, each with a -1 charge. So I'm going to call this technique an uncrisscrossing. And from this, we can see that there is 1 cation, there are 2 anions, for a total of 3 total ions. The next compound formula I see is MgS. So if I were to rewrite this so it's a little bigger, there's understood 1 here, next to both the magnesium and the sulfur. If you uncrisscross, it appears that the magnesium has a +1 and the sulfur has a -1. However, verifying this on the periodic table, magnesium is in the second column, which means it has to have a +2 charge, and the sulfide also has to have a -2 charge. So here we have to pay attention that just uncrisscrossing is not enough. You have to verify that those are the expected charges for those ions. So here we see, but we still rely on the subscripts to tell us how many of each ion there is. So there, in this example, there is 1 magnesium ion with a +2 charge, and there is 1 sulfide ion with a -2 charge. So there's 1 cation, 1 anion, for a total of 2 total ions. In our third example, this is ammonium fluoride. If I rewrite this, here's where you need to recognize that ammonium is its own ion, and I'm going to put parentheses around it to help us see that. And what this effectively means, there's not 4 ammoniums, there is 1 ammonium ion and 1 fluoride ion. If you uncrisscross, you'll see that the ammonium ion is a +1 and the fluoride is a -1. These are the expected charges for the fluoride and the ammonium ion. So we see here from the subscript there is 1 ammonium ion and there is 1 fluoride ion. So there's 1 cation, 1 anion, for a total of 2 total ions. In our next example, ammonium carbonate, here the ammonium is surrounded by parentheses with a subscript of 2 next to it. So that subscript right there is going to uncrisscross to give me the charge of a 2-. Now what's not as obvious is this carbonate, this CO3. You're going to have to learn to recognize that that's a polyatomic ion, and that 3 goes inside the parentheses. It's not telling you that there are 3 carbonates. Okay? So adding the parentheses here for emphasis, we recognize that there's really 1 carbonate. So when I uncrisscross, we see that there's a 1+ charge on the ammonium. These are the expected charges for ammonium and carbonate. Ammonium is a +1, carbonate's a -2. You can verify that on your polyatomic ion chart. So what we would do here is that there is 1 ammonium ion and there are 2 carbonate ions. So 1 cation, 2 anions, for a total of 3 total ions. Our next example is COBr3. These are not polyatomic ions, so we don't have to worry about the parentheses. So we can just do a direct uncrisscrossing. Here I'm going to rewrite the formula so I can write this a little bit more clearly. There's an understood 1 next to the cobalt. Uncrisscrossing, I see there's a -1 charge on the bromine. Uncrisscrossing the subscript of 3 tells me that the cobalt is a +3. Okay. So I see the subscript of 1 tells me that I had one of these cobalts with a +3 charge, but the subscript of 3 next to the bromine tells me that I had 3 bromide ions, each with a -1. So here you can see you need 3 -1 ions to match up with the 1 +3 ion to make it overall neutral. So here we have 1 cation, 3 anions, total of 4 total ions. FES, I'm going to rewrite this again so I can write a little more clearly. There's understood 1s here. Uncrisscrossing, this appears to be a +1 and a -1. Now, iron is one of those ions that can either be a +2 or a +3, but so this +1 ion for iron doesn't exist. So there's a red flag right there. We can verify this, that the sulfur or the sulfide ion doesn't exist as a -1, it exists as a -2. So because we know it's a 1-to-1 ratio, we know that this iron ion has to be the +2 version. So rewriting our inventory, we see that there is 1 iron ion. I'm getting that from the subscript in the formula. So there's 1 iron ion, it's a +2 charge. There's 1 sulfide ion. Again, I'm getting the 1 sulfide ion from the subscript, and that sulfide ion has a -2 charge. So here, 1 cation, 1 anion, 2 total ions. Our next compound is lead sulfate. I have parentheses here around the sulfate because we have to show that there are 2 of the SO4 groups. So this one's kind of nice because the parentheses sort of highlight that there's a polyatomic ion present. So uncrisscrossing, let's see what happens. The 2 becomes a +2 charge on the lead, and the understood 1 here on the lead uncrisscrosses to show that the sulfate is a -1. Verifying these charges, lead can be a +2 ion, so that seems like this is going along just swimmingly. But if we verify sulfate, sulfate is not a -1 charge, sulfate is a -2 charge. But to maintain that +2 to -1 ratio, we have to then assume that this lead ion is a +4 charge. Okay, so what we see here, from the subscript next to the lead, there is a subscript of 1. So there's 1 lead ion, and it is a +4 charge. There are 2 SO4 ions, each with a -2 charge. How did I know that there were 2 sulfate ions? By that subscript on the outside of the parentheses there. So 1 cation, 2 anions, 3 total ions. Our last example, Cu3PO4. Right? PO4, immediately you need to recognize that as a polyatomic ion. I'm going to put parentheses around it so that you don't misjudge that 4 to mean that there are 4 total anions. That PO4 is the polyatomic ion unit. It has to stay intact. So when you recognize phosphate as a PO4, you then see that there's only 1 phosphate in this compound. On crisscrossing, we see that the copper should have a +1 charge and that the phosphate should have a -3 charge. Verifying these ions, phosphate does indeed take on a -3 charge, Copper is one of those ions that can be more than one possible cation. Copper is either a +1 or a +2, so this one works. This one seems to be a valid combination. Now, doing the inventory, the 3 subscript next to the copper means that there are 3 of these copper +1 ions. The 1 subscript outside of the phosphate means that there is only 1 of these PO4 groups, and it has a -3 charge. So we see here that there are 3 cations, 1 anion, for a total of 4 ions. So this is how you do an inventory of ionic compounds. You have to first uncrisscross the compound formula to determine the cation charge and the anion charge. You'll need to verify that those charges are indeed actual charges, because the ratio might have been a reduced ratio. So definitely watch out for that to happen. The other thing you have to watch out for is recognizing your polyatomic ions and putting parentheses around them if you need to help you see that those atoms have to stay together. All right, see you back in the classroom.